Hello teachers, let's move on to chapter 13, section 13-2, where we're talking about areas of polygons and circles. So at the end of this section, you'll be able to understand and explain areas of rectangles, parallelograms, triangles, kites, trapezoids, regular polygons, circles, and sectors of circles. A lot of area formulas there. Conversions of area units, and ratio of area measures of similar figures. All right, so let's talk about a geoboard. You may have seen this before. It's basically an array of dots, and it's a good way to plot points, to talk about the slope of a line, and talk about area. And so we have an addition method for area. If you divide an area into smaller pieces, and then add the areas, then that's a good way to calculate area. So what is the area of this figure? So how could we do that? So we can kind of just count this up, right? So that would be 1 unit, 2 units, 3 units, 4, 5, 6. Now that looks like half a unit there. We'll come back to that. So 7, 8, 9, 10, that's a whole one, 11, there's a half right there, we're going to not touch that yet, 12, 13, 14, there's a part, 15, 16, 17. Now let's look at these parts, right? So that looks like about a half there and a half there. Remember, we were at 17, that would make 18. Now I'm not going to put 18 in both spots, that would make 18 there. Here's another half, and then another half, and that would make it 19. Now this looks to be exact. I mean, I feel certain that that is definitely a half right here that I'm shading in, and that's clearly a half right there, and so was the 19 and the 18 area. So let's just say this is 19. Now, you know when you calculate area, it's square units. So say this was an inch. Well, you can't say this is also an inch, right? Because this is calculating something different. This is 1 inch by 1 inch. I'm just using an inch as an example. That would give you 1 inch times 1 inch would be inches squared. Since we don't know what unit we're dealing with, we're just going to say units squared. But now area is always in units squared, whatever your unit is. And sometimes you're dealing with different units, so you would have to convert from one unit to another, which is not exactly the same as when we converted linear measure, which is just measuring distance from one unit to another. It's the same idea, but you don't do exactly the same thing, and we'll talk about that when we get there. And I have the typed up example here, 19 square units. They agree with us. Notice the difference too. I wrote mine as units with a little exponent up there. Why are we doing that? Because we know area, you just multiply 1 unit times another unit, right? So if I said 1 inch times 1 inch, that gives me 1 times 1 is 1, but inches times inches is square inches, but you could write it like that because it's 2 of them, so it's like there's an exponent there. So you might see unit squared or you might see square units. That does mean the same thing, okay? Now, back to our typed up answer, and let's just look at another one of these, or 2. All right, so the rectangle method is construct a rectangle encompassing the entire figure and then subtract the areas of the unshaded region. So that's a thought. So I went ahead and put the answer here because this was not totally clear to me, the way that they set this up. I think they're looking at this as like an approximation and not an exact area. And you see if you agree with me. So the area of the big square, okay, on the outside, you do see that that is, if you counted them all, let's do that. We haven't learned any formulas yet, so let's count them all. So just count the boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's where they got the 16 from. Again, just counting the boxes. Now I know what you're thinking is you're thinking, hey, in that 4 by 4 is 16. Yes, you're thinking right. That is the area of a square, is side times side. We just haven't gotten to that point yet. And what we're trying to do is talk about ways to help you and your students visualize area. And a geoboard is a nice way to do it. Now, look at this. They have 3 plus 1 plus 1 plus 1 plus 1, which gives you 3 plus 4, which is 7, and 16 minus 7 is 9. But let's talk about where they got that from. Now, remember, the 16 is the area of the square. What we're subtracting now is the non-shaded parts. So notice they started at the bottom down here. There's A, okay? And if you'll notice, around A, it looks to be approximately 3. Now you're thinking, isn't that too much? But look, there's this little piece here that would subtract from some of the blue. There's a little bit of white that would subtract from some of the blue, and then there's some of that there. So approximately is why they said A was 3. And then B, here's B over here. It's approximately 1. C is over here. It's approximately 1. Okay, now D is exactly 1. I feel good about D. And E is approximately 1. And that's where they got the 7 from that they subtracted from the 16 to get 9. But again, this appears to me an approximation. It could be exact. Those pieces we didn't count, like this white part here, and this white part here, and this white part here, might combine into those to make it exactly 9 units squared. But you see, this geoboard method is not going to work for everything. But it is a good way, again, to visualize area and what we're talking about when we mention area. Now, just so you feel well practiced with this, I want you to pause it and see if you can do this on your own. So again, the idea is find the area of this big square first, and then subtract out the white parts, the parts that you don't need. And let me go ahead and tell you, the final calculation has fractions, of 1/2 in it. So if you want to call some of your squares 1/2, because some is shaded and some is not, go right ahead. And let's just see if we get the same result. So pause it, try to find the area in blue by finding, again, the area of the big square and subtracting out the white pieces to see if you can get the blue part. All right, what do you think? Let me show you the typed up answer here. So if you got 4 square units, fantastic. If you got close to 4, I'm probably totally good with this. So let's talk about the area of the big square, right? So if I just kind of check off my boxes here, I'm going to do this in green. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's where this 12, that's the whole square. Now I'm going to erase all my green boxes and try to look at this in terms of the white parts. Okay, now notice they conveniently labeled this for us. Again, it is not required that you do yours the same way, but let's check it out. Okay, now A, they've got listed as 3, but let's take a look at that. It is fairly close to 3, because if you look at, there's 1, solid 1 right there. That's almost 2. Okay, that's another part, but then you've got this piece right here and this piece right here that would add in to say approximately 3. So A is looking like 3. Now B is a solid 1. Without a doubt, I feel totally good with B. Okay, now C they put as a 1/2, and I'm confident about that too, because that really is a true diagonal of that square. Therefore, the white part there where C is labeled is definitely a 1/2. I feel confident about that. Let's look at D. Hey, D is the same way. D is really a 1/2 of that square, so that's D. Let's check that off. And next is E. What do we think about E? Well, okay, E has got some blue stuff in it, but if you count this part next to it to kind of replace that blue stuff, E's not bad for 1. Okay, F is definitely 1, without a doubt. That's a clear 1. G, check it out. Here's G, right? It's got this blue stuff, but then there's some more white stuff here that might fill in that spot right there. So G is pretty close to 1 if it's not exactly 1. And then we've got 3 plus 1 is 4. Plus a half is 1 more is 5, 6, 7, 8. 12 minus 8 gives us 4 square units. Now, you might have started with 16, and then you would have to count an extra 1, 2, 3, 4, which would knock it back to 12. Notice they didn't bother to count those bottom 4 at all, and that's fine. You'd still get about 4 square units if you do this. Okay, so what about conversion? When we're changing metric units to area, how do we do this? Okay, so they tell us that a square kilometer is, oh my goodness, 1 million meters squared. Why? Right? Because remember, a kilometer is 1,000 meters. And then if you square that, 1,000 times 1,000 is a million. That's the way that works. A hectometer, or a hectometer, I don't know that that makes any sense, but a hectometer is 100 meters, right? So 100 meters. If I square that, that means I need 4 zeros, which would be 10,000 meters squared. A decameter is 10 meters. So 10 meters, again, if I square that, is 100 meters squared. A square meter, converted to a square meter, is just a square meter. But what about the decimeter? Well, remember, a decimeter is 0.1 or 1/10 of a meter. Well, if I square that, that turns into 1/100th of a meter. Okay? Centimeter squared. Well, centimeter by definition is 0.01 or 1/100th of a meter. Well, if I square that, y'all, it turns into 10,000th, 1/10,000th of a meter. And then finally, millimeter squared. So a definition of a millimeter is 1,000th of a meter. Well, if I square that, gotta even count this out, right? It should be a millionth. Am I right? If that works that way for the kilometer. But tenths, hundredths, thousandths, tenths, hundredths, thousandths, 10,000ths, 100,000ths. Sure enough, it's a millionth. Now, are you going to memorize this chart? Probably not, although the stuff I have over here in the green would be good to know. But let me show you the trick, and then we'll apply it to a problem. Remember King Henry? So King Henry died, your units right here, by drinking chocolate milk. And remember the trick when it was linear measure, if you move to the right, we would move the decimal 1 unit to the right. So if you went from, say, kilometers to decimeters, you would count 1, 2, 3, 4 moves to the right. Well, you know what you do for area? You move 2 places every time. So if I move from kilometers to decimeters over here, count by 2s. That's 2, 4, 6, 8 places to the right. Don't you love that? I think it's great. You could also use dimensional analysis. Remember, that's when you multiply by your fraction values that are equal to 1. But I love the King Henry trick, so let's try it for this problem right here. Okay, so again, how fast is it to write this King Henry situation? Oh, super fast, right? So King Henry died by drinking chocolate milk. Now, I don't care if you put the B right there, right? I like putting the blank there. You know why? Because we're talking about area squared today. We might be talking about liters another day. So this could be whatever we need it to be. But it's square units today, which means every time we move, look at this, that reminds us to count by 2s. So if I'm at centimeters, right over here, and I'm moving over to millimeters, that's just 1 jump, but it's by 2. So we're going to move 2 to the right. So if I've moved my decimal, which is sitting right here, to the right 2 units, I need to add 2 zeros. So this is 500 millimeters squared. Lovely, right? Fast, easy to do. There it is. Now, what did they do? dimensional analysis. Am I okay with that? Oh, I love dimensional analysis. It's my absolute favorite. But if you are teaching this for the first time to younger children, dimensional analysis might not be your best friend. You might have to slide that in later when your conversions get more complicated, or you might want to start hardcore and go ahead and show them from the very beginning, and maybe students won't hate these fractions so much. But it may be a struggle with some students, so giving them a King Henry story might be the way to go. This is up to you. It's your classroom. All right, next problem. Pause it. You do this one on your own. See what you think about it. All right, so I lost King Henry. How fast is it? Real fast. King Henry died by drinking chocolate milk. Here we go. So meters squared. So I'm right here at our units. Because I'm square, every time I jump 2. So I'm going to kilometers squared. So that's 2, 4, 6 to the left. Okay, my decimal's sitting right here. How easy is it to move over 6 places? Just like that, 124 kilometers squared. Now, you see their answer is also 124 kilometers squared. Good, right? They used, again, dimensional analysis. So they started with what we know, 124 million meters squared. Then they used the conversion. Remember what happens with your unity fraction over here is whatever unit you have here, you put it down here. And if there's a conversion from what you're canceling out to what you need it to be, then you use that conversion. And that conversion was on the chart. That remember it was, well, they're not doing it the same way. I would have put 1 million meters squared in the denominator and 1 kilometer squared in the numerator. So as you can see, I don't always agree with the textbook's typed up version, but what I do like is that you often see a different explanation for the same problem. So there you go. Did you catch what I was saying there? That I would have instead put 1 million meters squared is equal to 1 kilometer squared. Is that a different calculation? No. As a matter of fact, we're going small to big, right? Small to big is divide. Hey, that's another way to do it too, as long as you know those conversions. Okay, going to leave this problem now. Okay, you want to talk about something maybe you have never heard of, or maybe you have. But what about land measure? Us around here are very comfortable with an acre. Most of you have a good feel for probably the size of an acre. Maybe not, but English units we use an acre or a square mile to talk about land measure. Well, in metric units, if you leave this country, you're probably not going to buy acres. You're probably going to buy hectares. Okay, now you have an R, which is 100 square meters, and you might buy square meters instead of R's or hectares, but a hectare is 100 R, and then you have a square kilometer as well. So there's metric units, there's English units. Let's take a look at the conversion between. So again, that A represents R, and 1 hectare and 1 kilometer squared or kilometer squared. So 1 R is 100 meters squared. That is the definition. And I had that on the other screen too, that an R is 100 meters squared. And then 1 hectare, you can either say is 100 R or 10,000 meters squared, or 1 hectare meters or hectometer squared. We know what that is. That's your linear measurement, but squared, so it's area now. Okay, now the one I used in the homework, just so you know, is I used the fact that 1 mile squared was 640 acres. I think that one's worth really understanding. I don't own a lot of land, and I haven't bought a big plot of land, so I didn't really realize that 1 square mile was 640 acres, but I think that's something that's stuck in my head now. And again, it showed up in the homework, so you might want to commit that somewhere in your mind. Again, especially since you might have an idea of how big, say, 1 or 2 acres is. Well, Think about it. 1 square mile is big, y'all. If you had to walk around it, that'd be 4 square miles, right? Because it's 1 mile one way, 1 mile, turn that into a big square, and that's 4 square miles. That's a big plot of land, so 640 acres sounds about right. Okay, a square field has a side of 400 meters. Find the area of the field in hectares. Okay, just a side, so a square field. So let's picture this. So you have a square field right here, and it has a side of 400 meters. It's square, even though my picture doesn't look squarish. So area, right, would be 400 meters times 400 meters. Where would that take us? That would be 4 times 4 is 16, and then you've got 4 zeros. So 160,000, and this would be meters squared. Now, we need to go back and look at our conversion maybe, because we've got to turn meters squared into hectares, right? So if I look at my conversion, okay, 1 hectare is, right here, is 10,000 meters squared. So 1 hectare is 10,000 meters squared. I'm going to dimensional analysis and use that. Okay, so I'm going to write my fraction, again, right over here. Here's my fraction, have meters squared, and I'm trying to get rid of meters squared, so it goes in the bottom. So 1 hectare, remember what it was? Let's go back and look, is 10,000 meters squared. So I'm going to put 10,000 with the meters squared. All right, and then I have area equals, and I just need to multiply 160,000 meters squared and divide it, because that's in the denominator, by 10,000 meters squared. And if I just think about canceling a lot of zeros, let's see what happens. So I got 4 zeros here. I can cancel with 4 zeros there, and meter squared cancels with meter squared. So my answer should be 16 hectare. Okay, now let's look at their version of this. All right, so they took the 160,000 hectare and they just divided it by 10,000, which is different. See, it's different than the other problems that they did where they did dimensional analysis. But they're getting there, and again, you get to see different versions of the same type of problem. So how could you think about it in terms, you remember the trick when you're just converting. If you're going from big to small, so big means your arms are way out, stretched way out, into small, you cross them in front of your chest. That means you multiply. If you're going from small, which is like meters squared, to big, like hectares, you're going from arms crossed in front of you, you're tiny, and then you're making yourself big by stretching your arms way out to the side. You're making the division sign, because your head is the dot on top of the division bar, and then your body is the dot underneath, right? And so that means divide, and so that's one way to say it. We took 160,000 and we divided by 10,000. So, different ways. All right, let's do another one. Why don't you pause it and try this guy. A square field has a side of 400 yards. Okay, so again, if it takes drawing a picture, please do. So we have this square field, and the side is 400 yards. If it's square, that means this side is also 400 yards. We want to calculate area. Okay, I'm going to shut up now. Pause it, solve this problem, convert. How'd it go? Did you get it? So, first of all, area is 400 yards times 400 yards. You really should have put the yards inside each of there. That's going to be 4 times 4 is 16, and then all those zeros, yards squared. Okay? Now, if they weren't concerned about us turning that into acres, it would just be 160,000 yards squared. But what we want to do is turn 160,000 yards squared into acres. So I'm going to do dimensional analysis again. I hope there's a conversion from yards squared. Why did I put it in the denominator? Because I need that to cancel, right? Yards squared to acres. So let's go back and look that up. And there it is for us. Look, 4,840 yards squared is 1 acre. Okay, so I'm going to go back to my problem and replace 4,840 and 1 acre in my dimensional analysis. Okay, so 4,840, that's yards squared. So that goes with the yards squared, and that is 1 acre. And we'd already canceled the yards squared. So basically, if you think about it, I'm going from yards, which are small, to acres, which are big, and my arms are spread out, which means I need to divide. And that's exactly what's happening with my dimensional analysis. I'm taking 160,000 and I'm dividing by 4,840 because it's in the denominator. And when I do that, I get 33. I did it in my calculator, 0.06. I'm just randomly rounding to the hundredths place. This problem didn't tell me where to round. Remember, that is acres. Probably in the homework it might say whole acres. Let's look at their answer. Notice they said 33.1. They rounded to the tenths place. But you see, they did do it the same way. This time they did divide by the 4,840, which was the same as our dimensional analysis. Okay? Now, they were a little bit premature with that question, with both of those questions. Why? Because they're just now telling us what the area of a rectangle is. Actually, we talked about the area of a square, right? But not the area of a rectangle. Maybe that's the argument. We could go ahead and do that problem. So the area of a rectangle is length times width. So in this case, you see that our length is down here at 4, and our width is 3, so the area would be 3 times 4, which is 12. Now, I don't know what my units are, so again, I would just have to say square units or unit square. Remember, we decided that that notation is the same. Sometimes it's typed out with words, sometimes you use the little exponent up here. Okay, so that's the area of a rectangle. We could do some examples, but we really don't need to. How about the area of a parallelogram? Whoa, wait, what? Okay, look there. So it says the area of a parallelogram is base times height. Okay, now they're giving you two different versions of this. They're really making it probably overcomplicated. So our parallelogram is right here. Okay, now one way we could look at it is the base is B across the bottom, which would mean our height, that's like an altitude, right? Okay, our height is over there is H. Okay, now here's what you could picture. I know you could picture this. If I put, let me outline this in red. What if I picked that up and I just moved it over here? That would give you the area of a rectangle, right? That's why it's just base times height. It's the same as the regular rectangle formula, but the height is not one of the sides. It's the true height. A rectangle is the same thing as the height, but because you have a 90-degree angle, you're given the height right off the bat. So, now they have B times H, but also you could look at this the other way. If I erase all my drawings right here, okay, and look at this time, it says A times G. So A, they're looking at as the base here, as the bottom of the parallelogram, but the height would be in a different location. And it doesn't matter which one you do. It really is based on what information you have or can easily find. Okay? What about the area of a triangle? You know this formula, right? If you don't, you better commit it to memory. You need to know the area of a triangle. You need to know all of these. Okay? So area is equal to 1/2 the base times the height, where the height is defined as the altitude, exactly what we did before. So the base along the bottom here, so it's 1/2 of this times this, okay? Sometimes you don't have the height, so you have to do some tricks to calculate the height. But why did they show this picture over here? Well, again, imagine picking up this green triangle right here and reflecting it through this line, and there it shows up over there. That's just a parallelogram, and we just talked about how to find that area. So do you see where the 1/2 came from? It's 1/2 the area of a parallelogram. That's all a triangle is half of a parallelogram. Therefore, it's 1/2 the base times the height. All right, I have an example here for you. So this is a parallelogram. I know you see that. So it's going to be 1/2. The area is going to be 1/2 the base times the height. Not 1/2, I'm sorry. area is just base times the height. I still got triangles stuck in my head. All right. So you see we have, it's almost a confusing looking picture. You see you have the height is 8 centimeters. That is 8 centimeters. The base, is it 10? Is it 5? You want to go back and look and see how this is defined just to be sure? So here you go. This was where we defined really the area of a parallelogram, or gave the formula. And in this particular case, you see the base here, that's across the bottom, and the height goes to the base. So that might help you organize your thoughts. So again, what I'm looking at is here's the height. It goes to the base. Okay, so if we go back and look at our problem, okay, so here's our height, right here. That means it goes to the base. My base is down here. Now, it's not as long as I drew it because the height actually landed outside of the parallelogram. Is that okay? Of course it is. What we've got here, though, is the base. Look at my curly brackets. They're awful. Is 5 centimeters. So not the 10. The base is 5 centimeters. And if we multiply 5 centimeters times 8 centimeters, we get 40, careful, centimeters squared, right? Centimeter times centimeter is centimeter squared. So that is the area of that parallelogram. And there it is for me. Now, I've got another example, but I think I'm going to come back because I'm at 31 minutes. I'm going to come back for part 2. Hopefully, there will only be a part 2. I feel like there should only be a part 2, but I'm going to explain everything in detail. You know how I am. So I hope you have a wonderful day. Reach out if you have questions and come on back for part 2 so you can knock out this homework.